Good afternoon, class. We are looking at chapter 1 sequences, 1.6 sequences and difference equation for calculus for biology. And so that being the case, we've already covered a few pages. So we went over the definitions. This was the summary of sequences. We looked at the arithmetic sequence, which in short means we add a constant. We call it a difference or distance. In a case of a geometric sequence, we multiply by a constant and we call it a ratio. Then a formal definition of a sequence was given, and in this page we looked at a bunch of examples where the general term was given and we wanted to find the first 5 terms, and we did that. So let's go to the new example. This is what we have already covered, everybody. Okay, and just a quick recap of those are fairly simple. In this case, A7 was n, just 1 through 5. In this case was sine of n power 2. We went over circles, unit circles, and how we find quadrantal angles. In this case, C7 was n over 1 plus n, and in this case, the nth decimal place for pi is approximated by 3.14, but it's not equal to 3.14. So we should know with more digits, and that's exactly what we did here. 3.14159, and it continues indefinitely. Now, in this example, we want to find the first 5 terms, and again, you have all of these questions. You just write the solutions. So if I want the first one, basically, I'm going to replace the n with 1. I get a sub 1 equals 2 to the power of 1 minus 4, which makes it negative 2. What about a sub 2? Anybody? What do you think happens to a sub 2? What do we get? Anyone?
0.
Miriam, excellent. Excellent. 2 squared minus 4 results in 0. Can anybody give me the formula rather the answer for a sub 3? These two must be identical. 2 cubed, which is 8, minus 4, that gives us 4, and we can get the rest of them. Here's the list. Now, in this case, we want to go back where the list is given, but the general term is missing. We want to find that. For the first case, we notice the difference of 3, and it's an arithmetic sequence where a sub of 1 is 5 and these 3. And we use the general term a sub n equals a sub 1 plus d times n minus 1. We replace the a sub 1 with 5, d with 3. It results in 5 plus 3n minus 3. We can combine these two and we get 3n plus 2. You must always check. How do you check? If I choose n to be 1, do I get 5, the first term? If I choose n to be 2, do I get the second term 8, so on and so forth. So whenever you're done, the beauty of math is you can check your work. In this case, what do we notice? This is a geometric sequence with the ratio of negative 1/3. Why is that? If we multiply this number by negative 1/3, in other words, divide this by this one, you get negative 1/3. Divide this by this one, you get negative 1/3, and so forth. So if I multiply this one by negative 1/3, gives me negative 1/3. By negative 1/3 again gives me 1/9. By negative 1/3 gives me negative 1/27, so on and so forth. Therefore, it's a geometric sequence with the first term a sub 1 being 1 and the ratio of negative 1/3. Therefore, I'm going to use the general format or general term for a geometric sequence, which is a sub n equals a sub 1 r to the power of n minus 1. So I'm going to replace the a sub 1 with 1. I'm going to replace the r with negative 1/3. And this is what I get. Now, 1 times negative 1/3 to the power of n minus 1. Now, anytime we have a negative sign, we want to separate that into a format of negative 1 to some power. So we take this 1 to the power of n minus 1, and then 1/3 to the power of n minus 1. Because in general, for alternating signs, we use one of these two. Please understand, negative 1 to the power of odd, any odd number is negative 1. Negative 1 to the power of even is a positive 1. So negative 1 to the power of 1 gives you negative. Negative 1 to the power of 1 minus 1, or 0, because any number to the power of 0 is 1, that gives you positive. So notice the first one, if you plug in 1, that results in 1. I'm going to show you by reminding you that a to the power of 0 is 1. And for the 1, if I plug in 1 into this, and again, you can use this one and this one, but we rather use this one for the sake of alternating sign. So let's plug in 1 here. When we plug in 1, we get negative 1 to the power of 0, 1/3 to the power of 0. Anything to the power of 0 is 1. 1 times 1 is 1. Remember, negative 1 to the power of any odd number, such as 1, 3, 5, 7, and so forth, becomes negative 1. Negative 1 to the power of even numbers, like 2, 4, 6, 8, is positive 1. Remember that. Difference equations, again, we had them in summary. We're going to repeat that. Sequences are sometimes created recursively, specifying the next term given the present. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one, and it may not always be possible to determine the general term of the sequence algebraically. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. An example of that, you may recall the Fibonacci sequence, which starts from some number, then it repeats, and then they add up. So if F1 is 1, F2 is 1, then the next one is the sum of those two, which is 2. The next one is the sum of those two, which is 3, and so forth. So in general, we're going to write F sub n is F sub n minus 1 plus F sub n minus 2, meaning if you want a term, find the previous two terms and add them up. This is true for n larger than or equal to 3. So can anybody tell me what would be the next term here? All you have to do, add up these two numbers, and it's 34, and you can continue. If I want the next one, I add up 21 and 34, and I get 55, and so on. Example in nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. So the first year we have 1, the second year we have 1, the third year we add them up, we get 2. The next year we add them up 2 and 1, we get 3. The next one we add them up, we get 5, so on and so forth. Let's practice with the recursive sequence. So find the first 6 terms of the recursive sequence. A sub 1 is 6, A sub n plus 1 is A sub n over n. So if we were to define it for ourselves, it means if I want to find a term, I pick the previous one and divide by the number of that term, first term, second term, and so forth. So if I'm interested in the next one, which is A sub 2, then I need, and you can set this as n plus 1 equals 2, therefore n is 1. Therefore, I want A sub 1 over 1, which is 6 over 1, which is 6. Can anybody tell me what is the formula for A sub 3? What would be the formula for A sub 3? So just set n plus 1 equals 3, and n becomes 2. So A sub 2 over 2, 6 over 2, or 3. Can anybody give me the formula for A sub 4? Anyone?
A sub 4 and then equals to A sub 3 over 3, which is 3 over 3, which equals 1.
Perfect. Here's A sub 3. And the answer is 1. And you can write the rest of them. I suggest you work on A sub 5 and A sub 6 just to be on the safe side. Excellent. Part B. So we have A sub 1 as 1. We have A sub 2 as 2. And the general form is A sub n plus 2 is A sub n plus 1 plus 2 A sub n. Meaning, if I'm looking to find any term, I pick the previous one. And then I multiply the one before that by 2 and add them up. So, again, understanding this formula. what should be the formula for a sub 3? In other words, if we change this to 3, we say a sub 3 equals what? Anybody?
It's a sub 3 equals a sub 2 plus a sub 1.
Excellent, excellent, excellent. This is exactly what she says, and that means 2 plus 2 times 1, 4. One way to look at this class, if n plus 2 is 3, n becomes 1, right? So just replace this with 1, replace this with 1. It's really that simple. All right. Let's try a sub 4. Let's give everybody a moment. Let's try a sub 4, everybody. A sub 4. The formula should be, let me just erase this. So now you want this one to be 4. If n plus 2 is 4, n plus 1 is 1 less than that. 3, and this is 1 less than that. 2, or you can say if n plus 2 is 4, that means n must be 2, and do the math. So a sub 4 is a sub 3 plus 2 a sub 2. A sub 3, we know it to be 4, plus 2 times 2, they add up to 8. Okay, class? Formula for a sub 5, anybody? Formula for a sub 5. Using the same methodology, it's a sub 4 plus 2a sub 3. Eight plus 2 times 4. They give us 16, and we continue with the next one. All right. Here's the last one for this page. A sub n plus 1 is 2, a sub n minus 4, where a sub 1 is given as 3. Okay, everyone? Write the formula for a sub 2. Write the formula for a sub 2. And then work it out. What do you get? What would be the formula for a sub 2 according to this? And again, you can say, oh, this is 2. N plus 1 is 2, n becomes 1. Right? So a sub 2 is 2, a sub 1 minus 4. Because a sub 1 is 3, 2 times 3 minus 4 gives us 2. Right? What about a sub 3? If this is 3, if n plus 1 is 3, n must be 2. So 2 a sub 2 minus 4. As you know, a sub 2 is 2. 2 times 2 minus 4 makes it 0. If you can find 2, you can find them all. It's not a big deal, everybody. So here's the list for the 6th term. Suppose C sub t is the concentration of a drug in a bloodstream at time t. A inflow is the concentration of the drug that is administered at each time step. And K is the fraction of the drug that is absorbed in a time step. What is the recursion that models this dynamic? First, let me explain the concept. When we are dealing with patients and medication, somebody's taking a painkiller, a pill for headache or a blood pressure, things of that nature. So the doctors say, okay, so you can take it every 6 hours, every day, every week, every month, and so forth. That would be your time step. Time step, there are a lot of factors that will go in calculating the time step. One of the most important thing is the weight. And it's not going to, enter our calculations here. So when a patient takes medication, a portion of that will go away, will be absorbed by the body by the time the patient receives the next dose. If 10% is gone, 90% remains in the body. That's the fraction we're talking about. If 2/3 is gone, 1/3 is left. If 1/4 is gone, 3/4 is left. That's the idea. That's why it plays a big thing. Now, the general form, we go with n sub t plus 1, and we say it's n sub t. That means if you want the next one is the previous one, plus what comes in minus what goes out. Now, let's do it symbolically with math. First of all, instead of n, I'm going to go with c because it's c sub t here. So c sub t plus 1 is c sub t plus inflow. Inflow, A, minus outflow. Now, remember, what is the outflow? The fraction that is absorbed, K times N sub t. In this case, K times C sub t. Again, I want to make sure we understand it when we do it in the next part. If we combine these two, everybody, becomes 1 minus K times C sub t. Please understand this part. Now, here's the important part I want to make sure everybody understand. So next time, this much is left from the previous one. How much is left? If K is 10%, 90% is left. If K is 90%, only 10% is left. Plus what? The amount of constant, the inflow that we add for every time step. If the initial concentration is C sub 0 equals 120 micrograms per milliliters, and A is 80 microgram per milliliter, and K is 1/2, plot some points on the graph of C sub t. So what I want to do, before plotting, I want to show you how we arrive at it, and then we take it from there. To do that, anytime you're dealing with a word problem, you want to write them symbolically. So C sub 0 is given, A is given, K is given, so you want to write that. And now you're going to put that into this equation. By the way, C sub 0 normally is 0 when we are dealing with patients to begin with, they don't have any medications in the body, okay? But anyways, so with that being the case, we are going to write C sub t plus 1 is C sub t 1 minus 1/2 plus A is 80. Everybody knows 1 minus 1/2 is 1/2. So that's a general formula now. If C sub 0 is 120, the next one would be C sub 1. So what is C sub 1? Half of C sub 0 plus 80. We've seen this stuff, we should be fine. So if this is 1, this becomes 0, right? If t plus 1 is 1, t plus 1 is 1. So half of C sub 0 plus 80. And what is C sub 0? 120. Half of that is 60 plus 80 makes it 140 micrograms per milliliter. The next one is C sub 2. If this is 2, if this is 2, T becomes 1. So C sub 2 is half of C sub 1 plus 80. So what is C sub 1? 140. Half of that, 70 plus 80, 150 micrograms per milliliter of the medication. Now, can anybody tell me what would be C sub 3? Half of this, 75, plus A, 155. And here's the formula for it. C sub 3 is half of C sub 2 plus 80, everybody. Okay? Now, what I want to add is a very important part, and we will look at this concept of a limit later on, and it will make a perfect sense, okay? But for now, you know, I want to explain the concept quickly, but this is referring to the concept of a limit. What happens when we keep up with the medication and we never stop? Well, if we never stop and it adds up to a point that could be harmful to the patient, it makes no sense. So what happens is that they calculate how much they can give to the patient, okay, and what would be the time step. So this time step with this inflow has been calculated in such a way that it can never ever go beyond some value that can harm the patient. And it can be proved the limit is A over K. Later on, when we go over the limits, you'll see how this one is proved. But A is 80 divided by K, which is 1/2, and that gives you 160. Okay, so it will never go beyond that. If we were to put those points there, it creates what is called a horizontal asymptote, which will never go beyond 160. All right. Could somebody be kind enough to read this for us? Please. Can somebody read this, please? There are a few parts I want you to help me out.
Example 6, Pacific salmon populations have discrete breeding cycles in which they return from the ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species.
Excellent. Could you please continue?
Suppose that each fish must first survive production by bears while swimming upstream, and production occurs with, the screen's a little blurry,
Probability D.
probability D. After swimming upstream, each field produces 6 offspring before dying.
B offsprings. Okay, so if
Oh.
it's, let me read that. Then if it's, maybe you have an internet problem. So suppose that each fish must first survive, and I thank you so much, survive predation by bears while swimming upstream, and predation occurs with the probability of D. After swimming upstream, each fish produces B offsprings before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to the sea. What is the discrete time recursion for the population dynamics, assuming that there is no mortality void at sea? you should count the population immediately after the upstream journey. There's a second one. Suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Finally, which of the two recursions, parts A and B, predict the largest increase in population size from one year to the next? Justify your answer both mathematically and in terms of underlying biology, where D is between 0 and 1 and B is larger than 0. As far as D, I want to make sure you understand D represents the probability, and it's between 0 and 1. It's never negative, it's never larger than 1. It can be equal to 0, it can be equal to 1. In this case, they said it cannot be, but in general it can. So the first case, part A, we are going to start with so many fish. How many? It's your choice. You can say X, Y, Z, or N, or we're going to go with the time step N sub T. This is the number we start with. It doesn't matter what you choose as your variable. So what happens? Predation with the probability D, meaning if 10%, so if the bears take 10%, 90% remain. If they take away 1/3, 2/3 of the fish remain, okay? So in essence, this one times 1 minus D. The way I'm going to write it, I'm going to write this one N sub P is the previous one minus D times N sub T. D times N sub T is the predation. This is the amount that will be lost, will be taken away by the bears. And when we put them together, 1 minus D times N sub T. So if you don't want to write that, if you understood what I said, you can just right away write 1 minus D times N sub T. Now what happens? They get up there, and each one give us this many fish, B. But they die. So simply put, you have two choices. You can multiply this one by B, and that's fine. Or I want to show you this step is N sub P. It adds B times N sub P, and then minus N sub P because they die. So this many fish get up there. They give us B each one, B times N sub P. But since they die, we're going to subtract that. So in short, it becomes this one times B. Finally, we add M. That many fish. So let's recap. First, we have so many fish. You can use any variable of your choice. Some percentage is gone. Let's say 10% is preyed upon, 90% is left. That's why we get 1 minus D times N sub T. Each one produces B offsprings, and all of them die. So simply put this one times B. And then we add how many? M. So this is the first format. Okay, this is the first recursion, if you will. Here's the second recursion. Suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. So here's the difference. First, again, we have the same number, N sub T, just as previously. But now they give us B offspring before dying, so B times that. Then we add how many? M. So add M. Final step, they have to deal with the bears. So whatever percentage is gone is gone. 10%, 20%, 30%. 1 minus D is the percentage which is gone. 1 minus D times this number is the final number that remains. So we had two recursions. The first one, predation happens when they go upstream, and the second one, when they come back. Again, you have all of these. The questions are given to you. We're just looking at the solution. Which of the recursions obtained in parts A and B predicts the largest increase in population size from one year to the next. Justify your answer both mathematically and in terms of underlying biology. You can assume these between 0 and 1, B is positive. Obviously, this is positive because B is the number of offsprings. And this one, the reason they don't, again, it can be equal to 0, it can be equal to 1 statistically, okay? But the reason it's between 0 and 1 because of the situation in this case. So we have these two to compare. Which one gives us more? Any ideas? Which one would, what do you think? Anyone? Well, you can discuss it, from the biology point of view and see what happens. But what I'd like to do, I'm going to start with math. And the way it works is very simple. If you calculate part A minus part B, if it's positive, part A is larger. If it's negative, part B is larger. So this minus that. And all you have to do, elementary algebra, distribute, FOIL, simplify, see what you get. So we're going to do that. So this one, B times 1 times n sub t, B times n sub t, B times minus D times n sub t is minus BD n sub t plus M. So the first bracket is very simple. This one, you do the FOILing, 1 times B n sub t 1 times M minus D times B n sub t minus D times M, and you keep the negative sign out. So this is simply FOILing. Now I'm going to distribute the negative sign, and everything here changes sign. So this one doesn't change. This is minus B n sub t. This is minus M. This is plus BD n sub t. And this is plus MD. Notice these two cancel each other. These two cancel each other. These two cancel each other. We end up with MD, which is positive. Therefore, clearly part A gives us more. Why is that? As far as the biology point of view is concerned, it makes sense. So part A gives us more. All the additional fish survive. Remember, in the first case, we add M fish at the end. However, in part B, all fish have to deal with predation, including the M that we added. So notice 1 minus D times that. So mathematically and from a biology point of view, it makes a perfect sense.